Thank you for joining us tonight. Going to do a quick sound check so people can check their video and their audio. You should be seeing some video on your screen, and now you should be able to hear me. Good evening. Welcome to our TI Technology webinar hosted by Texas Instruments. This is the second in the series of How To with your TI-84 family of graphing calculators. My name is Ruth Casey, and I'm the moderator for this event. We'll be using the WebEx channel to share comments or ask questions. So when you use the WebEx to send a chat, okay, select everyone from the drop-down menu. Let's try it now. We invite you to select everyone, share your name and location. Your name might be appearing, but if it isn't, go ahead and put it in there. Send out a greeting to everyone. That's the WebEx chat. Choose everyone. There are some other options like all panelists and all attendees. Choose everyone so that our presenters can see what you're sharing, and so that other participants can as well. So just a minute to look up and down that chat. Oh, great. Thanks for telling us your locations. If you experience any audio or video issues tonight that can't be resolved through the WebEx panel, please feel free to come back and watch the recording later. Yes, it is being recorded. I am so pleased to have two amazing educators with us tonight, John Lemaster and Stuart Moskowitz. John, Stuart, thank you so much. Please say hi and tell us a little bit about yourselves.
All right, hi, I'm John, and I am from Fort Wayne, Indiana, where I teach at Purdue University, Fort Wayne, mostly to college freshmen, mostly to students who walked out of high school saying, math, I don't remember anything, and I had no idea what happened. So then I take them from there.
Hi, I'm Stuart, and I recently retired from Cal Poly Humboldt, on the north coast of California, and I taught in the math department, as well as doing primarily math education courses for future teachers.
Thank you.
With the agenda, I'm just going to jump on in, Ruth.
Great.
And for tonight's agenda, we're going to investigate graphs and tables from multiple perspectives.
Okay, after they're finished with presentations, John and Stuart will be happy to answer questions that might have come up in the chat. Okay, so remember, share with everyone in your chat your questions and comments. Then we're going to have a webinar drawing. One lucky viewer tonight will be the winner of complimentary registration to the 2022 Virtual T-Cubed International Conference. We will also be sharing the link for certificate of attendance for tonight's event.
And I want to add, too, that this entire webinar is being recorded. So rather than trying to keep up with what we're doing, why not just sit back and enjoy the show and perhaps take a few notes, and then later on you can review it again for more details. Hopefully by the end of the hour, you'll have a much better understanding of what the top row of the calculator, what that top row of keys can do. You will have an understanding of the, whoops, where did that go? You'll have a better understanding of the,
my bad, Stuart.
graph is. Polar graphing, like you never thought, because we can actually do it with middle school kids now, and we're going to try to make as many mistakes as we can so we can understand what error messages are all about. Okay, John, go for it.
I just jump in. Maybe it was over caffeinated tonight. I want to share with you my screen, and you've heard already we're recording, and what also you'll have is a handout too. So when you get the handout after this webinar, that is going to make it even easier for you to follow at your own pace with the handout. So rather than keep up with us with your calculator, this is actually part 2 of a webinar series, and part 1, I'm going to put in the chat a link to it. and you can see that webinar later if you're interested. And it talks a bit, I'm going to do a little segue between part 1 and part 2, where we played with the table. And I have this little one here that I typed on my home screen. And what I'm going to try to do is build a pattern with a rational function. And so what I'm going to make is I'm going to press 1, and then I'm going to use this shortcut alpha F1, which gives me the N over D key. And what I'd like to do is 1/3, and then I'm going to notice that I had to use my right arrow, and I'll hit a plus. And oh, I'm going to turn off my video so I don't have it on. Or maybe I won't. All right, I'll leave that off. All right, and now I'm going to change it to plus a half, and then I'm going to multiply it by 1/3. Now, why I'm doing this, we're going to notice that we're going to use graphs and tables, but what I'd like to show you is here's another alpha x shortcut. A shortcut for the fraction is alpha x. And we do 1 and then divide it by, and what I'd like is a 3 here. And I will see that I have a nice entry, which is now if I can continue this pattern, I'm going to build a numerical table on my home screen and then tie it to the table feature. One of the ways, okay, this is really cool. I have 3 ways that I'd like to share with you how to do something similar to copying and pasting. And one of the things that is neat about this is it uses the history. And the first way is to climb up, and I'm just going to drop this down and select it. It's kind of like plucking the fruit off of the tree. And then I'm going to change this to 1. I'm going to increase each of these denominators by 1. And a quick way to get to the very beginning of the line is second left arrow. And so I can now just follow the little walk through the field here and grab this and change this to 1/4 plus a 1/3. And now we're going to see a pattern. So if I were to guess what might be the next one, if I did 1/5 plus a 4th times a 5th, maybe you could write in the chat what you think it'll be. And while you do that, so I'm going to ask my students, what do you think is next? And here's another way we can copy and paste. I'm going to actually need a 1/5 in my expression. So here's what I'm going to do. I'm going to use this alpha x shortcut, and I'll do 1/5. And what's neat about this is I can now use this building my entry lines. So I'm going to climb up here and grab this and pluck the fruit. And then I'm going to add, and then I'm going to do plus, and then alpha x. I need a 1/4. And then I need that 1/5 again. So I'm just going to climb up there and pluck the fruit. And I pluck the fruit by hitting enter. And now if okay, I see in the chat, you nailed it. Yeah. All right, great. And so that's the second way to copy and paste. And we can kind of build this pattern that maybe we can just look at this middle one. And what I'd like to essentially do is I'm going to show you this handout that you're going to get, where we can see how the pattern could go, and I could go and ask for some wacky thing like 100 plus 99. Now, if I want that, I'd like to show you a third way I can copy and paste. I'm going to do this. This is sort of really cool. Second, and you notice this recall in the first column, second recall, and it's asking me recall what? And I stored some things in a sneaky place. I'm going to press the alpha shortcut button. So we're looking up here at the top row, and I stored something in Y0. Now you don't know that, but I do. So I'm going to be, as the teacher, pulling this out of the hat here. I'm going to go back down there and grab it. I could also just type 0, I suppose, and hit enter. And I'm recalling that expression. And now I can ask this, and you're probably guessing correctly. What is Y0? Let's show that. If I go all the way down to the bottom to Y0, there it was hiding. I stuck it in there. And I left it so it's unhighlighted with my equal sign. That's a way to kind of store stuff that you can recall later, and it will recall anywhere you want in wherever your cursor is sitting. So the next thing that I'd like to do is I'm going to show you in the handout that what is the goal is to try to build this expression. Oh, yes. And Michael, I like your point. The regular way will work also. I could use the stacked fraction, or I could use the other one, but this is called thin bar division. And if I use this, the advantage of this is that sometimes this, well, there's going to be some advantage with this expression when I have this in auto mode, because in this mode, I'm not getting the pretty answers. And I'm going to notice if I'm fract it, which is another fun thing. Let's go to alpha and, well, let's go to math. Math 1, then, oh, see, I have to actually type it right. This does get a little bit fun. I'm going to insert this and my order of operations. So insert, and it's a great question. What is the advantage? And I'm not going to show you all the advantages right off the bat, but you're going to see some more. Oh, there we go. 100 and, oh, okay. So cute thing that I've done is times 100. So what I want to share with you is if I grab this back here, let me go back to this. And I have this at the very last ending of the line. Oh, this is something also I want to share with you. You can clear out your history and delete anything you don't want in it to make your pattern look pretty. So you can just hit delete, and that's another cute thing you can do with your history pair. And then if you don't want things showing that your your scratch work, you can kind of get the full pattern on your table. So you can always clean up your table here. And there, now what I'd like to do is share with you yet another way that you can copy and paste. So I did the history climbing where I selected enter. I did the second recall, and here I'm going to now grab this. So this is the last, we call this the entry. If I hit enter, this is the entry. And so if you notice this blue thing, second entry, if I go to y equal, this is where my cursor is sitting. If I hit second enter or second entry, I get the entire entry line plastered where I teleported. So now this is a not what I want to graph, but I want to change this to say x plus 1 to kind of build a pattern. And what I like about what we did on the home screen, now that we've got a graph in our y equal editor, you're going to use the graph, is that I can confirm what I did on my home screen with what is going to happen on my numerical table. So there is a table here that is up here, second table. And if I look at my second table set, and maybe I'll start at 0, you can get the fractions here. And if I had used, Michael, the division key here, these would not look as a stacked fraction as the output. They would look as decimals if I'm in auto. So that's the other advantage. I can actually show you that because I can ask any, well, I'll show you that later. All right, let's go back though. This is my y equal, and I have now an expression. And what's really, really fun is that you can now evaluate a table with your Y1. I'm going to go to alpha F4 or alpha trace, and I'll do number 1, and I can stick in values in here just as I did before, and explore, well, what would happen if I had 1 over 99. And I can notice that you can stick in any value in here. I'm going to climb up here and just replay that. That can explore if this pattern works for any number. Oh, this is delish. Let's grab this and stick in this fraction. Can I highlight him? And he popped in, and I just do a little bit of tidying up. And it would have been nice had I cleaned it up a little, but it pastes exactly right on top. It doesn't overstrike and everything. So there I have that. And building this, I can get confirmation in here. I'd like to show you a feature of the table that's really handy, that you can enter. This is, Michael, what I wanted to share with you, and now I'm going to. You can enter anything you want if you change your independent to be free, which is this name of independent, but you can be independent is ask. And now if I go to second table, I can stick in 1 divided by 2. And notice it doesn't show me the stacked fraction. But if I put in alpha 1 divided by 2, I can put in fractions here. And so they preserve the stacked fraction. I'm going to go back to auto to show that something's interesting happening at -1 and 0 with this. And the goal, and you and I have seen this already in our life, is we want them to be able to simplify this expression or add these fractions. So what we want to do is manipulate by getting a common denominator, and then we would get some rules here where, oh, we can strike that out and write that and say, guess what? It does work for any value of x. But I was told, and probably you were too, when you learned this, depending on your level, that this is exactly 1 over x. And just to keep the lawyers at bay, we added contingency clause. Not all. And if x is -1, we don't. So what is nice is people the students at the beginning will look and say, oh, there's my answer. It's hiding right there. So it's kind of fun to see that tied in, and it helps them own the idea of simplifying this fraction. I don't know. My students usually don't cry more. I want another one. Maybe yours do. But now let's do the graph. If I press, there's a standard feature here, and I have a zoom 4 going on. And what I'd like to do is notice, oh, this is interesting. Look at my y equal. Did you notice that there's some wacky stuff happening in here that may look different? This was not intentional. Well, it was intentional. Intentional to show you that sometimes your students will get wacky stuff happening, and it's because transformation graphing is on, and based on what model you're using, you may or may not be able to actually use any y's down here. So one way is to highlight this quit app if you have an 84 CE. And the other way is if you actually go to apps and climb to the very top. I wanted you to see that when you graph, it really happens that sometimes that transformation is on by accident. And so I'm going to hit the quit. Now, if I go to zoom 4, I'm going to find that that's zoom decimal. Let's see what happens. And this is another error. If you might have noticed, this says invalid dimension. And if I hit the quit, look what'll happen. There's a plot that got highlighted. So one easy way is to get up there. I just impose hands and say, be healed, and hit enter. And there I have a plot. Now, if things go bump in the night, as we mentioned, common errors, this should graph. And look what we've got. Something is really happening. When we press the trace, you'll notice that at 0, the function had nothing showing. And, well, it said it had nothing here in their coordinates. And it had climbed in steps of decimal values. So what does zoom decimal do? The easy thing to do is look at the window. We'll press window, and this is actually the trace step is climbing in steps of 0.1 or 1/10. Now, I said 0.1 because it's actually not the fractional, it's the decimal 1/10. And when we trace, we are climbing in that step, and we're getting the outputs with our fractional values because we use the n/d key here. What's also neat to see is that you can just at any time trace on any value. I can actually get this to land on -1 because of it being a friendly window, and it'll say, sorry, no value for you. So we got a nice graph with this window, and I have that you can get some kind of idea of what's happening with this by noticing that I went from -6.6 to +6.6, which means that that's 100 and
I'm going to interrupt here. John, we don't hear you. So you may have accidentally muted your self, or I'm not sure what happened, but we are not getting audio from John. And as Jay has pointed out in the comments, yes, number of pixels in each direction is indicated by the window there. We have 132 columns across our graph screen. John, let's test your audio again. We do need your audio. Do you want to stop sharing your screen for a minute? Will that help you find your audio? I'm still not hearing you. All right. So, oh, I heard something.
Okay, can you hear me now?
I can hear you. Yes, I can.
Okay, thank you. All right, I'm going to close in just a minute then. Thank you very much. Believe it or not, I didn't have mute, but I think it was because of pushing a button that closed my video that I cleaned up. So I'm not sure where we lost my video, but 1/10 is actually the trace step here. And if I look in my handout, I'd like to show you that the trace step is actually telling you your x min minus x max divided by the number of pixels on the screen, which you don't have to ever memorize this, because in your calculator, if you just hit zoom decimal, you can double this 6 6/10, or watch this. Zoom, and I'm going to go all the way to the very tippy top. Press the up arrow, which gets me to the bottom, and zoom 1/10. And now, when I trace, I actually am getting those reciprocals. 3/5, 5/3. So I'm actually getting the fractional reciprocals here with my tracing with a zoom fractional window. And now you can now let's press zoom standard, which is our typical place since it's called standard. And I'll notice that the hole did not show. And that's because when I look at my window, I'm now at 20 divided by 132. And your calculator isn't very friendly. There's my last trace step. That's very unfriendly. And so it's lighting up pixels and connecting them with lines to be able to graph this. And I'd like to show you something really, really essential for you to know. If I'm on trace, oh yeah, it is an awful window. If I'm on trace and I have showing these coordinates, if I simply type -1, I can get to any value I want to it's called smart trace by just simply typing, and that works for minimum and maximum and intersection as well. So um, I'm going to liberate my cursor, and so notice the cursor looks kind of like a spider here, or a flower petal. And if I liberate it, oh yes. So if I press trace, I'm on trace, so I have the trace coordinates showing, and the trace coordinates are evaluating the x value at the function up here. If I simply type the number I want, it doesn't matter. I don't have to trace on it. I can evaluate it. It's exactly the same thing as second calc value right there. It's just a shortcut. And you bet. So now I'm going to press that. If I liberate this, I just have to get off trace. So if I press graph and now I liberate the cursor, it looks a little different. It looks like a plus. And these are very ugly. Now, if I go back to zoom decimal and liberate my cursor, I have a very friendly window. So all of those frac windows, here we go, zoom frac, will give me a friendly window, but will trace in that step of 1 over the fraction that's showing. And that's a real powerful feature. There's one other simple feature that's cute to know, and that is this thing called XRes. XRes, I'm in a decimal window. XRes is default to be 1. If I change it to, say, 6, what is interesting is the graph doesn't look very nice. Yes, to liberate the cursor, I want to get off of trace. And to get off of trace, I can press the graph button. So XRes now, because I set it to 6, is highlighting every 6th pixel and connecting them with lines. So if I went to 7, it would highlight every 7th pixel. That's not a good graph. The maximum is 8, every 8 pixel, and the screen resolution speeds up the graphing, but it lowers the quality. It's your caffeine indicator. So the default is a 1. And sometimes when you're playing with other apps, they may change this and you may not know it, like transformation graphing. So it's so nice that we've looked at the graph in the table. I want you to notice that there's more even that you can do with this. And Stuart will share other techniques of the graph. But the other cool thing is, look at the handout. We've got even more riches.
All right. Well, thanks, John. I learned something new from you every time. And so it's always a pleasure to work with you, especially some of those Zoom features that you picked, especially the Zoom frac ones, the 1/10 and those down there. Excellent stuff. And so I'm gonna continue, change gears a little bit, but I can't help but see Jay commented how Zoom standard is such an awful window. Jay, I couldn't agree with you more. And so let's have a look here. I'm going to pull up my 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 emulator, my 84 emulator here, and I want to study linear functions right now. And let's see, have you ever had a student, a parent or even students or maybe even administrators say that your kids shouldn't be using calculators for graphs in a beginning algebra class because they'll never learn how to graph if they can just put in the function and press the graph key. So let's put in a function. How about this nice linear function right here? And let's press the graph key. But I want to make sure I am, well, first off, notice that the equal sign is not highlighted, but y2 it is. So I only want to look at y1 right now. So I'm going to move the cursor down to y2. I'm going to put the cursor right on top of the equal sign and press enter. And that will toggle the equal sign, so it's no longer highlighted at y2. I'm going to go up to y1 and press enter. Now I'm going to go zoom standard. Let's look at that horrible zoom standard window. Oh, there it is again. John, that's the same mistake John made. And I know that he did it. I wanted to do it again because this is probably the most common error you're going to see. How come I keep getting this error message? And there's no go-to. It doesn't take me to the source of the error. So I'm going to press 1 to quit, and I'm going to go back to y equals, and you will notice that plot 1 is highlighted. In other words, if I had gone second stat plot, notice that plot 1 is turned on and the others are off. The quick way to turn it off is to go up to plot 1 and press enter. And often that's how it gets turned on accidentally, is that you arrow up without thinking about it, and you press enter to come back down, and you can turn on plot 1. So here we go. Zoom standard. And where's the graph of, where's my function? I don't see anything. You have to be smarter than your calculator. That's what this is about. Now, of course, I am making a point of choosing a function that's going to take some work to find it. And the calculator can't find it for me. So I have to be smarter. And I use the term a complete graph is my goal. I want my students to be able to sketch a complete graph. That means I want all the important behavior to show up in the viewing window. That means I want axes, intercepts, I want any critical points, I want discontinuities, everything to show up. The linear function, that means axes, intercepts are what's important. So let's see, where is it? Great place to start here is just press trace. And when I press trace, it's always going to be on the center column of pixels, which is x equals 0. And notice that it says that y equals 80. Well, that you probably knew that already, but instead of me, it's not going to be obvious to all your students. So how do I get the graph to show up if y equals 80 needs to be in the display window? Well, that's window settings. So I'm not going to, I want to ask the students, what do I change? X min, X max, Y min, Y max, what has to be changed? And so what does have to be changed? And you're absolutely right if you're thinking Y max. So let's go past 80. How about 100? Again, there's no single right answer here, but let's see what we get when we change Y max to 100. Maybe 90, maybe 200. And look at that. We can see the graph of y1. And it's a horizontal line. And if you're happy with that, well, then you're not thinking. You're letting the calculator do the thinking. And no, the calculator doesn't know how to think. So the fact that this thing has a slope, the slope is not 0. This shouldn't be a horizontal line. So I know it has to cross the x-axis. Before we get to that, I want to ask this question of why does my y-axis look so weird here? This looks like a zipper. Let's go back to to the window and notice that with y going from -10 to 100, and y scale is the key here. With y scale equal to 1, that means it's going to show it's going to put a tick mark for every unit, and that's just too many tick marks. We just don't have enough rows. So I'm going to change Y scale to 10. I'm going to go back to graph. And let's see, did I see that somebody made a comment using Zoom Fit? Well, the problem with Zoom Fit is that it doesn't always give me it won't necessarily give me a complete graph. Zoom Fit tends to make a linear function go from one corner to the opposite corner. And I need more control than that. But it's certainly a fair question. You know, why did they put it there? I find that Zoom Fit doesn't work for me. Rarely does Zoom Fit give me the graph that I want. Here, if I just go Zoom Fit, we can do that. Where is Zoom Fit? Remember that arrow down there means there's more than 9 of them. I'm going to go up, and I see that Zoom Fit is at 0. So I'm just going to type 0. And here it is. This is what Zoom Fit gives me. Not at all what I wanted. So did you know that you can go back one window? If you go Zoom and go to Memory, go Zoom Previous, and that'll take me back where I was. So now the question comes up, so I want to find the x-intercept. Again, the calculator's not going to find it for me. There is nothing here in Zoom that's going to find it. So I need to do a little bit of I've got to do some algebra. I can do some guess and check, and there's nothing wrong at all with guess and check. First off is, does this thing have a positive slope or a negative slope? Since we have a positive 1/1000th, it's a positive slope. That means it's going to intersect the x-axis way to the left, way to the left. That means I got to change x minimum. How about -100? So I can do guess and check, but you can see this might end up taking me a long time. What if I did 1,000? I can keep doing this. Still, this is going to take a long, long time. So let me press trace again here. This 1/1000th, let's see. I can do a little bit of algebra and solve for x. That would certainly, let's see. I can let y equal 0 and solve for x. That's one way to do it. I can keep doing guess and check. Whatever method you use, again, encourage your students to be creative here. What if I said -100,000? Aha, there it is. Again, guess and check eventually worked. Now, I do have a y-intercept, but let me go back to window, because x minimum is so many magnitudes greater than x maximum, I don't like the way it looks. I'm going to change x maximum, say, to 10,000, just so that, and that would mean I better change x scale. Otherwise, we're going to get way too many tick marks. Let's let x scale be 10,000 as well. And I finally have a nice graph here with the both axes intercept showing. I have a complete graph. Before I move on, I want to do one more thing with this. It's really a nice little trick here about if you want to do any computation with coordinates that are on this graph. Now, first, if I press trace, and look at how ugly these coordinates are. Now, I could find a friendly window that John talked a little bit about, using the number of pixels, the 132 pixels. I could go with that. But as an exercise here, let's calculate the slope. Let's use these ugly, ugly numbers to calculate the slope. And let's do it right here on the home screen. And notice that these two numbers that are showing right now, if I go back to the home screen, okay, and I just type x, notice that the coordinates that we're showing are saved by the calculator. But if I'm going to find slope, I need 2 points. So I got to put this somewhere else. So let's take that x value and store it. I'm going to go to my keyboard, the stow key, which is to the left of the 1 key. And how about if we put it in A? We've got the entire alphabet. We have 26 variable locations, as well as plus theta, that we could store it in. Let's store x in A. And let's take the y value, that's alpha y, and let's store that, how about in B? And by doing this, that means I can go back to the graph and go grab another point, because I've saved this XY pair. So let's go somewhere else. I'll press trace. Maybe I'll take this one right here. And again, it doesn't matter which point. I can take any 2 points. So I'm going to go back to the home screen. I'm going to take that X value and store it in C. And I'll take the Y value, alpha Y, and I'm going to store it in D. And now I'm going to use the slope formula to solve this. And I love this fraction template, alpha X. And I'm going to use the slope formula. I know it's the difference in the Y values. That's D minus B. So alpha D subtract B. There's the difference in the Y values. And we're going to divide it by the difference in the X values. That would be C subtract A. And now all I have to do is press enter. And there we get it. And notice we were able to use again, taking any 2 points off of the screen and capitalizing on the fact that I can use the XY coordinates, but I never like to keep them there. That's why I moved them into A, B, C, and D. Okay. I want to encourage you to come up with other functions of your own, to have students exploring. I do have a handout that there is a handout posted that will go over what we just did. But I also have another one that I've used in class. It's sort of like a little quiz with a half a dozen different functions. And please send me an email and I'll be happy to send you this other handout so that you could use it. It's classroom ready so that you can use it. Just to give you an example, and I don't want to take too much time because I've got other things I want to share with you. Here's another example of a function that isn't going to show up. Let's see, let's turn off Y1. So I deselect the equal sign on Y1, and I'm going to select the equal sign for Y2. Notice that we have a quadratic times a linear factor. Okay, I'm going to go back. Even though I don't like Zoom Standard, I'm going to start with Zoom Standard. And oh, it looks like this is a parabola. Look at that. It's a parabola. Or is it? Remember, sketch a complete graph. That means all axes intercepts must be showing and all critical points must be showing. So trace is a good place to start. And let's see, when I press trace at the y-intercept is negative 144. So I'm going to change y minimum. Oh, how about negative 200? See what that gives me. Still looks like a parabola, but no, it's not. It doesn't quite have the symmetry. And so this is why it's so important to be smarter than your calculator. We have a cubic function here. Okay, we know there has to be a third zero, and I think you can see where that third zero is. Since it's in factored form, that third zero is at x equals negative 16. So I'm going to move x minimum. How about negative 20? And we're almost to a complete graph. I would like to be able to see where that minimum value is, and if I press trace, look at that. Y is at negative 704. And again, just using the arrow keys, I see negative 777, negative 800, negative 844. Look at this. We're down to negative 950. Oh, we're down to negative 1,000. Whoops, now we're coming back up again. Looks like about negative 1,015. I'm going to make sure I go past it. How about negative 1,200? And then let's let Y max be 100. I like to get it into the same order of magnitude. I'm going to change scale, and let's see if we've got a complete graph. We can see critical points, and we can see all the axes intercepts. And we know that because it's cubic, that it won't turn around and come back again. We also know because it is a negative cubic that it has to start at positive infinity and end at negative infinity. So we have to use a lot of the algebra that we have to use much of what we know in order to make this come alive like this. One more thing before we leave this behind. I want to confirm where these zeros are. Okay, we haven't used that before, so I want to make sure that we see how to do this. I'm going to go second calc. Yes, Michael, you can use minimum and maximum to find that. Again, absolutely, you can use min and max. I found that, sometimes just tracing to it will also get me that approximate value. In fact, I will need to use min and max if the activity, if my teacher is asking me what is that minimum value, then yes, I will use minimum to find out what is that, where that value is. But I want to focus on the zero here. I got a reason for looking at zeros instead of the minimum right now. I'm going to go second calc. I'm going to choose 0. That's number 2. It's asking for a left bound. So I think we know that we should be seeing it at -16. So I need to move it to the left of -16. So let's get it to the left of -16. The cursor's off the screen. That's okay. Right bound. I don't need to go right to move it over. I could just type, how about -6? And now I've restricted the domain. I'm going to look for zeros in between that left bound and the right bound, and I get a 0 at -16, 0. Okay, let's go find the other one. 0. It should be there at 3, right? So how about a left bound at 0? And how about a right bound at 5? And let's look for a guess. And it gives me an error. Interesting. Another error. It can't find it. And that's because, and notice again, there's no opportunity to go to the source of the error. All I can do is quit. So I'm going to quit. I'm going to go back to the graph and try to understand what's going on. Looking for zeros is not about finding where the y value equals 0. It's what the calculator is doing is looking for where it goes from positive to negative. It cannot find a 0 if that critical point has a multiplicity of 2 or 4, if it's an even multiplicity, because it does not go from negative to positive. So in this case, the only way I'm going to be able to find that, again, I need to understand that particular 0 happens to be at a critical point. It's a local maximum. And yes, I could use the maximum to find it. So I'll go to maximum. How about a left bound of 2 and a right bound of 7? And as long as the guess is in between, and then it can find it. Look at that. There's another interesting little glitch why you got to be smarter than your calculator. Is that maximum really at 3 and 5/10 millionths? And it didn't really find a 0. That's times 10 to the -12. What's going on? The calculator is using a form of Newton's method, and it's doing an approximation. It's getting as close as it can, but its tolerance level is like 14 decimal digits. So when it gets to within a certain level of accuracy, it says that's good enough. And so it's important for you and your students to understand that when you get numbers like this showing up, it's probably, and this is where you need to confirm by looking at the algebra, x would have to be 3 to get me 0. Okay. Please review the handout. If I know that I'm going through this very quickly, I want to make sure that I have a few minutes here to talk about polar graphing, because I didn't study polar graphing until I was in 3rd semester of calculus. And as soon as I had a graphing calculator in my hand, I found what wonderful things I could do with it. And really, the only background that my students need is to know that there are 360 degrees in a circle. So let's change radians to degrees. And let's change the graph mode from function to polar. And now we're going to go back to y equals, but notice it's not y equals anymore. I'm going to press clear. We don't want to have that there. It's r equals, and r stands for radius. And I know some of you perhaps haven't done polar graphing for a long time, but let's just think about this. Radius. How about a radius of 6? Whoops, not +6, just 6. Constant function. This is probably, again, a constant function is about as simple as it gets, but I'm not going to say it's simple. Let's try zoom standard and see what we get. An ellipse. Wait a minute. But where am I getting an ellipse? Notice that I'll press trace, and we see that x equals 6. And let's scroll. Notice here, I'm going to go to window so that you can see that theta, we now have a new parameters here, theta going from minimum to maximum, 0 to 360, in increments of 7.5. That's the default. So let me press trace again. And notice that theta is advancing in increments as I press the right arrow key. It's no longer going from left to right. It's going from theta minimum to theta maximum. And we see that sure enough, the coordinates are at 6, 0 and 0, 6. And why is this not a circle? Well, it's not a square screen. It's a rectangular screen. And so here's another reason why Zoom Standard is not a very good window. Zoom Standard will always be -10 to 10 and -10 to 10, which was fine when you were drawing it on a chalkboard, but not on a rectangular graph screen. So for the purposes of what we're doing here, Zoom Square will be just fine here. And look at that, Zoom Square. And what Zoom Square did, it left y's alone. It didn't do anything with y minimum and maximum, but it changes x minimum, x maximum, so that the aspect ratio, so that the distances on the axes will be the same. Notice the tick marks are spaced the same on the x-axis now as they are on the y-axis. And so I get a circle with a radius of 6. But it's not really a circle. If I press trace, it's plotting points every 7.5 degrees, and it's connecting the dots with straight lines. So let's see, 360 divided by 7.5, 360 divided by 7.5. Oh, so that's really a 48-sided polygon is what we're getting, not a circle. If you want to get a better circle, how about theta step equals 1? And now it'll be even better. It doesn't look much different because resolution is such that they basically looks virtually the same. So the 7.5 is good enough. And while it doesn't seem to matter with the emulator and with a handheld device, the smaller the theta step, that's 360 points, it's going to slow things down. So the 7.5 is sort of a nice balance where it still looks like a circle, but it's fast enough for most of the handhelds. And some of the older black and white ones will be even slower. Well, the way that my brain works is, gosh, if I can get a better circle with a smaller theta step, what would happen if I used a bigger theta step? What if theta step were 60? And you picture what's going to happen before I press graph. It's going to plot a point every 60 degrees, and it's going to connect the dots with straight lines. And I didn't catch who just wrote that in the chat, but you're absolutely right. If we only are going to put points every 60 degrees, look at that. My circle is now a hexagon. So as I said, if your students know there's 360 degrees in a circle, then what would it take to get a pentagon or a square or a triangle? Let's see. If I want to get a square, I need to plot 4 points around the circle. How far apart are they? How many degrees apart are they? You got it, 90 degrees. Press graph, and we get a square. How about a pentagon? Well, I know that there's 5 points, and maybe you don't know what 360 divided by 5 is. So let's try 360. Look at what I'm going to type here. I can type through, whoops, and that's not what I wanted to type. That's not where I wanted it. I'm going to press clear, 0. Let's put it here on theta step, 360 divided by 5. And I'll press enter, and it'll do the computation for me. When theta step is 72, I get a pentagon. So what a great exploration for the kids to be going back and forth, trying to get all these different polygons, trying to understand the exterior angles of a polygon. And we don't have to stop with polygons. Let's see. If I've got a pentagon, when I go to consecutive vertices that are 72 degrees apart, could I make a star? Is that possible? Let's see. What if I was to go, instead of going from the x-axis to 72 degrees, what if I were to skip one and go to the next one? What if my theta step was 144? See what happens. Graph. Aha. I press trace, and there's the 144 degrees. There's 288. It looks like I'm starting to draw a star, but why didn't it finish? We went from 144 to 288. I need to go another 144, another 144. I need to go around the circle again. So let's go back and change theta max. Let's go around the circle twice. Change that to 720. Cool. I remember the first time I saw this. This was so exciting to be able to all of a sudden a circle becomes a star. And with a little bit of exploration, I don't want to give you all of the, this is not something that you want to watch me do. I want to encourage you to go exploring and see how many different polygons you can get and explore a little bit. If you were to change that 6 to a theta, you can turn it into spirals. And I'm only going to show you, I'm going to change this back to a 7, let's see, let's just change this back to a 3 and press graph. And you see, well, it grew way too fast. I'm going to change, maybe I'll slow it down a little bit. How about 1/10 theta? And this X key here, because I'm in polar mode, if I press the X key, I get theta, and I got 1/10 theta, and now I'm turning my circle is becoming a spiral. Well, it's not a circle anymore, but I can start exploring spirals too. So I am going to stop here because we're just about out of time. I hope that have just given you things to explore. This is supposed to just be a beginning. And please don't hesitate. We went through this really fast. Don't hesitate to email me. You get a lifetime guarantee with every webinar that I lead. And I know I can speak for John in regards to that too. And you'll have our emails on the handouts. I'm going to go ahead and put my email right here in the chat for you and turn it back to Ruth.
Thank you. Thank you. Great stuff, Stuart and John. So check your chat. They'll have their emails there. Also, some links will be in your chat. I put a link to the documents. I'll put that again. You'll get some email with the information about the documents and the recordings. And remember, it's recorded. You can go back and watch. We'll leave the chat open for a little bit after we sign off in case you have some other questions or comments that you want to share with John and Stuart. All right. Questions there. Okay. Webinar drawing. All right. So while I had to quit watching, I had to stop watching what Stuart and John were doing and look through the list of participants. I used my random number generator on my TI-84 CE, and the winner is Kimberly Malone. Kimberly Malone. Congratulations, Kimberly. You will be receiving an email from a TIer and with more information about the complimentary registration for the virtual conference in July. All right. And
Say that Stuart and I are going to be part of that. We're going to have a presentation. It's called What's on Your Table. So if you can get to that, we'd love to connect again.
Excellent. All right. And so next in the chat is coming out the link to your certificate of attendance. And again, you'll get this in a follow-up email. You had to give them your email to register for this event, so you'll get the link to the documents, how to find out about the certificate of attendance. All right. So there was the certificate of attendance. Did I link that? I was talking and I actually couldn't press buttons at the same time. All right. Documents. That's the link to the documents. It'll come in email, and in a few days you'll be able to find it on the TI website where you registered. But if you want them now, I have them. So I expect that some of you are anxious to get them. Let me put it in the chat rather than up there on that screen. All right. So I sent that out in the chat. As you're leaving the webinar, you can save the chat file. So not only will it save all of the great questions and comments, it can save these links as well. All right, I think I covered everything I was supposed to do. We had the webinar drawing, certificate of attendance, a link to the documents. Thank you so much, John and Stuart. Very, very exciting. We can't wait to find out more. And I think I remember, Stuart, you said if we email you, you'll send us something else. What was that?
I have put together a friendly windows that we could be used in a pre-calculus class. Whoops, you can't see that.
That's all right. Okay.
That's okay, but it's a classroom ready worksheet that will have a half a dozen different functions that you and your students can explore.
Excellent. Thank you so much. Thank you, John. Thank you, Stuart. Thank you, attendees, for the great engagement in the chat. As I said, we'll keep the chat going for a little bit. If you have other questions that you'd like to send to John and Stuart. Thanks, everybody. Good night.
Good night, all.
Good night. Thanks.